You think time is always moving, always ticking, always flowing, always there, even in the darkest corner of space, even in perfect silence, even for everything that exists. You imagine light traveling through time, just very, very fast. You imagine a photon racing across the universe while the cosmic clock keeps ticking beside it. This picture feels obvious, it feels unavoidable, and it is wrong. For light, there is no ticking clock, no waiting, no duration between here and there. The journey across billions of years does not take time, not slow time, not distorted time, no time. You think motion requires time. You think change requires time. You think existence itself unfolds moment by moment. But at the deepest level of physics, the universe permits something that experiences no before and no after. And if that is true, if time itself can disappear, then your entire intuition about reality is unstable, not incomplete, unstable. You carry a quiet assumption about time. You believe the universe shares a single rhythm, a master clock, one continuous unfolding moment. You never see this clock, you never touch it, but you assume it must exist. Right now, you imagine that the same now spreads everywhere, across your room, across your planet, across distant stars. You believe events are placed along one shared timeline, like beads on a single string. This feels unavoidable, but physics does not contain such a clock. There is no universal ticking behind reality. To see the problem, consider something simple. You check your watch. It reads noon. Somewhere far away, another watch also reads noon. You instinctively assume these moments are the same moment, synchronized pieces of one global time. But how would you prove that? To compare the watches, you must send a signal, a light signal, and that signal takes time to travel. So when you look at a distant clock, you never see it now. You see its past. Even across a room, the delay exists, tiny but real. Across space, the delay becomes enormous. A star you observed tonight may no longer exist in its own present. Your sense of shared time is built on delayed information. Already the idea of one universal moment begins to fracture. Now imagine two observers moving differently through space. One stays on Earth, another travels rapidly in a spacecraft. Each carries a precise clock. Each measures time carefully. Each trusts their own experience. When they reunite, the clocks disagree, not because one is broken, not because of measurement error, but because time itself unfolded differently for each. There was never a single shared flow. What you call time is not a global river carrying everything forward together. It behaves more like a personal measurement, tied to motion, tied to position, tied to the path you take through reality. Time does not happen to the universe. It happens to world lines, to individual histories. This is the first crack in your intuition. Time is not universal. Time is local. And once you accept this, even reluctantly, a deeper question emerges. If time can differ between observers, how far can this difference go? How slow can time become? How distorted can this personal measure of change be? Push the idea far enough, and you reach a strange possibility. Not slower time, not warped time, but the complete absence of time. A situation where the interval between two events simply vanishes. This sounds impossible, yet the laws of physics quietly point toward exactly this limit. You believe motion happens inside time. You imagine time as the stage. Objects move across it. Clocks measure it. Speed simply tells you how fast something travels while time continues untouched. This is wrong. Motion does not occur within time. Motion reshapes time. To see why, imagine a simple clock. Not a mechanical one, but a beam of light bouncing between two mirrors. Each bounce marks a tick. Light travels up, reflects, travels down. Tick, tick, tick. This clock measures time using motion itself. Now place this clock inside a spacecraft drifting quietly past you. From your point of view, the light inside does not move straight up and down. It travels diagonally, chasing the moving mirrors as the ship glides forward. The light covers more distance. More distance means more time between ticks. The moving clock runs slower. Nothing is broken. Nothing is resisting. Time itself stretches. This is not a trick of perception. It is not about how things appear. If the traveler returns and compares clocks with you, the difference is real. Their clock records less time. Two histories, two durations, one reality. This is the strange discovery formalized by Albert Einstein. The passage of time depends on motion. The faster you move, the more dramatically time changes. At ordinary speeds, the effect is tiny. You never notice it while walking or driving, but as speed increases, the distortion grows. Time bends further, processes slow, chemical reactions lag, aging itself stretches. You are not merely moving through space differently, you are moving through time differently. Push this idea further. Imagine a traveler moving faster and faster, approaching the ultimate cosmic speed limit, the speed of light. With each increase in speed, their clock slows more relative to yours. Minutes for them correspond to hours for you. Hours correspond to years. The progression is not gentle. It is relentless. Time compresses toward stillness. This leads to an unsettling implication. If increasing speed slows time, what happens at the limit? What happens when motion reaches the maximum allowed by the structure of reality? The mathematics gives a severe answer. Time does not merely slow, it stops. Not metaphorically, not approximately, exactly. The moving clock would cease to tick, but here intuition rebels. Motion seems to require time. A process that unfolds must have duration. A journey must take time. The very idea of change without time feels contradictory, and yet physics insists on this direction. As speed approaches light, time approaches zero. To understand why the universe enforces such an extreme rule, you must confront something deeper than motion, a fundamental boundary built into reality itself, a speed that does not simply describe how fast something goes, a speed that reshapes the structure of existence. You think the speed of light is just a number, a very large number, a record no object can beat, like a cosmic traffic rule. But the universe does not treat it like a speed. It treats it like a boundary, a structural limit woven into space and time themselves. To understand this, imagine throwing a ball from a moving train. If the train moves forward and you throw the ball forward, the speeds add. The faster the train, the faster the ball appears to an outside observer. This is how motion normally works. Speeds stack, velocities combine. Now replace the ball with a beam of light. You might expect the same logic. If a spacecraft moves forward and shines a flashlight, the light should travel faster relative to someone outside. The speed should add, but they do not. No matter how fast the spacecraft moves, the light always travels at the same speed. Always. To the traveler, to the observer, to everyone. Reality bends to protect this rule. This was one of the most disturbing implications of modern physics, emphasized repeatedly by Richard Feynman, that the universe adjusts measurements of space and time so that light's speed never changes. Lengths shrink, time stretches, simultaneity dissolves. All to preserve one constant. This means the speed of light is not about light itself. It is about the geometry of reality. It defines how space and time fit together. And when you approach this boundary, the adjustments become extreme. Imagine again the moving clock made of bouncing light. As your speed increases, the light inside must still travel at its fixed speed. But from an outside perspective, the path the light takes grows longer and longer. To keep the speed constant, time itself must stretch. The faster you move, the slower your time flows. This is not optional. It is required for the structure of space-time to remain consistent. Mathematically, the effect grows without limit. As speed approaches light, time dilation increases toward infinity. The rate of change collapses. Every process freezes relative to the outside world. At the exact speed of light, the equations produce a stark result. The interval of time along that path becomes zero. Zero duration between events. This is not saying time feels slow. It is saying time disappears from the description entirely, but something else happens simultaneously. Space itself collapses along the direction of motion. Distances shrink toward nothing. The path between 2 points contracts. Space compresses. Time vanishes. The closer you come to the speed of light, the less meaningful both space and time become in their familiar forms. The universe does not allow objects with mass to reach this boundary. The energy required would become infinite. Reality protects the limit, but light does not struggle against this barrier. Light exists at the boundary, which raises a disturbing question. If motion at this speed eliminates time and erases distance, what does existence look like at that limit? What would the journey of light actually mean? You are tempted to ask a simple question. What does light experience? If time stops at the speed of light, you imagine the photon witnessing a frozen universe. You imagine a strange point of view where everything happens instantly, where the beginning and end of a journey blur together. This question feels natural, and physics refuses to answer it, because the question itself is not allowed. In relativity, every description of reality depends on a reference frame, a viewpoint moving at some speed, carrying its own rulers and clocks. From such a frame, you can measure distance, you can measure duration, you can describe events unfolding, but there is no valid reference frame moving at the speed of light. You cannot ride alongside a photon. You cannot construct a clock that travels with it. You cannot define what it sees. The equations themselves break down at that boundary. Why? Because the very tools used to describe experience, time, and space collapse there. A reference frame requires a functioning clock to measure change. It requires measurable distances, but at light speed, time intervals shrink to zero, and spatial distances contract away. There is nothing left to measure. So physics gives a strange answer. We can describe what happens around light, but not what happens for light. And yet the mathematics still points to something unsettling. Consider a photon emitted from a distant star and later absorbed by your eye. From your perspective, the journey took millions of years. The light crossed enormous distances. It traveled through expanding space. It endured a vast history. But along the path traced by that photon, what physicists call its world line, the interval of time between emission and absorption is zero, not small, zero. Two events separated by cosmic distance are connected by no duration at all. This is not an interpretation. It is a direct consequence of the structure of space-time. But notice the tension this creates. We cannot say what the photon experiences, yet we can say its path contains no time. We are forced to talk about a journey that has no duration, a process with no passage, a connection without becoming. Your intuition resists this violently. A journey must take time. Movement must unfold. Cause must precede effect. But at the speed of light, these familiar structures lose their footing. The framework you use to understand reality, before and after, here and there, then and now, stops applying in its usual form. The universe permits connections that do not resemble experiences, and this pushes us toward an even more unsettling consequence. If a process can occur with zero duration, what becomes of distance itself? What does separation mean when time no longer links events? You believe distance guarantees separation. If two events are far apart, you assume something must travel between them. A journey must unfold. Time must pass. Distance demands duration. But at the speed of light, this connection breaks. Consider again a photon leaving a distant star and later reaching your eye. From your perspective, this is a vast journey. The light travels across space for millions or billions of years. It crosses unimaginable distances. But along the photon's path, the interval of time is zero. And here is the consequence most people miss. If no time passes along a path, then distance along that path loses meaning. Because distance, as you understand it, is something measured through time, a separation bridged by motion, a gap that requires duration to cross. Without time, the idea of traveling across space begins to collapse. In the geometry of space-time, the emission and absorption of the photon are separated in your description of the universe. But along the photon's trajectory, these events are directly connected. No temporal gap, no experienced interval. From this perspective, the photon does not cross space. The endpoints are simply linked. The journey and the arrival become inseparable. This does not mean the star and your eye occupy the same location in your world. It means the structure of reality allows a connection where separation does not require duration. Your intuition insists if something moves from A to B, there must be a sequence, first here, then there. But for light-like connections, the sequence loses its ordinary meaning. The concepts of between, during, and while traveling fade away. There is only the relation between events. This begins to blur the boundary between cause and effect. You normally imagine cause unfolding into effect through time. A process develops. One state transforms into another. The arrow of time organizes reality into a chain of becoming. But when time along a path is zero, the link between events is not mediated by duration. The emission of the photon and its absorption form a direct connection in space-time structure, not instantaneous in your frame, not stretched across time in its own, simply connected. This strange feature is built into the universe's rules of communication. Nothing can transmit influence faster than light because light defines the limit where duration collapses. It forms the boundary separating events that can affect one another from those forever disconnected. Reality organizes itself around these light-like links. The universe becomes a network of events connected not by flowing time, but by geometric relationships. This challenges another deep assumption, that the world is made of objects moving through time. Instead, physics increasingly describes a world of events related by structure, where what matters is not the passage between them, but the connections allowed by space-time. The idea of a continuous journey begins to look like a human interpretation, a way of organizing experience rather than a fundamental feature of reality. And once you see that duration itself can disappear from the universe's description, a deeper question emerges. If time is not required for fundamental connections, if it can vanish entirely under certain conditions, then what exactly is time? Is it a basic ingredient of reality, or something that emerges from deeper relationships? You were taught to think of time as something that flows, a river carrying the universe forward, a steady background in which reality unfolds, a fundamental ingredient of existence itself. But the behavior of light forces a different possibility. Time may not be a thing. It may be a relationship. To see this shift, consider how physics actually defines time, not as a substance, not as a universal current, but as a measurement, a way of comparing change between events. A clock does not capture time itself. It tracks motion. It counts processes. It compares one change to another. The ticking of a clock is simply a repeating physical event, a vibration, a rotation, a transition. Time is the number you assign when you compare those events to something else happening in the universe. Time is not what flows. Change is what happens. Time is how you measure it. This idea becomes unavoidable in modern physics. What you call time depends on the path you take through space-time, the particular sequence of events that defines your history. Different paths produce different durations. There is no single master timeline underneath them all. The universe contains events. It contains relationships between events. It contains measurable intervals along different paths. But it does not contain a global ticking clock. This is the deeper lesson hidden in relativity, developed from the work of thinkers like Hermann Minkowski, who proposed that space and time form a unified structure called space-time. In this picture, time is not separate from space. It is one dimension among others, woven into the geometry of reality. Objects do not simply exist in time. They trace paths through space-time. Your life is not a moving present moment. It is a trajectory, a continuous sequence of events forming a world line. What you experience as the flow of time corresponds to moving along this path, measuring the intervals between its events. But light follows a very special kind of path. Along that path, the interval, what we call proper time, is zero. The geometry itself assigns no duration. This suggests something profound. Time is not guaranteed. It is not universally present. It appears or disappears depending on the structure of the path connecting events. Just as distance between 2 points depends on the geometry of space, duration between events depends on the geometry of space-time. Time becomes a feature of relationships, not a background container. And this reframes your everyday experience. You feel time passing because your body undergoes continuous change. Your brain processes sequences of events. Your memories accumulate in ordered layers. The sense of flow emerges from the physical processes that constitute you. But the universe itself does not promise this flow everywhere. At its deepest level, reality is described not by a moving present, but by a structured web of events, a vast arrangement where past, present, and future are not fundamental categories, but perspectives defined by different paths through space-time. And in certain extreme cases, like the motion of light, the category of temporal duration disappears entirely, which leaves us at an uncomfortable edge. If time is not fundamental, if it emerges from deeper structure, then your most immediate experience of reality may not reflect reality's true nature at all. What you call the passage of time may be a local feature of your existence, a condition of your perspective, not a property of the universe itself. You experience reality as a sequence, a continuous unfolding, one moment replacing another, a moving present sliding from past into future. This feels undeniable because it is the structure of your experience. Memory preserves what has been. Perception reveals what is. Expectation reaches toward what will be. Your mind organizes existence into a flow, but physics does not require this flow. At the deepest level we can describe, the universe does not appear as a story being told moment by moment. It appears as a structure, a vast arrangement of events related by geometry, not driven by a universal passage of time. In this structure, some paths contain duration, some paths contain change, some paths contain experience, and some paths contain none. Light traces such paths. The fact that time vanishes for light is not just a curious detail of physics. It reveals something unsettling about reality itself. The universe permits connections where no time passes. It allows relationships that do not unfold, processes that do not progress, links that exist without becoming, existence without duration. Your intuition struggles here because your entire life depends on time. Thought requires sequence. Cause requires order. Identity requires continuity. Remove time from your experience and the familiar world dissolves. Yet the laws of physics calmly allow this removal. They describe a universe where what you call before and after are not absolute features of reality, but local ways of organizing events. The sense of a flowing present may not be a fundamental property of the cosmos, but a perspective arising from the particular path you follow through space-time. You do not witness the universe as it is. You witness the universe along a trajectory that generates time. From another kind of trajectory, like that of light, reality contains no waiting, no aging, no interval between origin and destination. The universe simply connects events. This suggests something profound and unsettling. Perhaps the passage of time is not the engine of existence. Perhaps it is a condition of observers. The universe itself may simply be a complete structure, a timeless arrangement, a reality where all events coexist within a geometric order beyond the language of flow. Physics does not fully understand this picture. Even today, the nature of time remains one of the deepest unresolved questions. Theories of quantum gravity attempt to describe a world where time may not exist at the fundamental level at all, where duration emerges only as an approximation within complex systems like you. We do not know. But we know enough to see the edge. Light reveals that time can disappear. Reality allows existence without temporal experience. The universe does not guarantee the flow you feel, and this leaves you with a final tension. Every second of your life is shaped by time's passage. Every thought depends on its sequence. Yet the deeper laws governing the cosmos quietly describe a world where that passage is not universal, where, at the limit, it vanishes completely. You live inside time. The universe may not.